Okay, what we're going to work on today is looking at a two-armed if so that we can do an if-then-else structure, and we'll use that to make a graphical user interface that shows some three-dimensional objects. We'll draw a horizontal or vertical line down the middle of our screen, and if our mouse pointer is on the left of that line, we'll draw a cube, and if it's on the right of the line, we'll draw a sphere. So we'll begin with our template sketch or template program that we had from chapter 3, and the idea is we're going to modify this to do our if-then-else program. So I'm going to change the comments here first to illustrate or to be specific to what we're doing. So we're going to make a sketch to draw a red cube or a green sphere. Based on the location of the mouse pointer. There we go. And we'll change this to be today's date. Okay? Now, in terms of our methods, we will need a setup and a draw, but we won't need mouse clicked. So I'm going to go ahead and eliminate that method for right now. And then I'm going to put in some comments at the beginning of my methods so that I know what I'm going to do with them, and then we'll go ahead and begin our coding after that. Okay, so setup is still called at the beginning of the program, and all we have to do here is size the window, and we're going to turn on 3D rendering so that we can see our images, our cube and sphere in 3 dimensions. Then in terms of draw, what we're going to do is a little bit more complicated, but if the mouse is on the left side of the frame, we're going to draw a red cube at the mouse location. Otherwise, we're going to draw a green sphere. Okay? And then we'll go back and we'll fill in those pieces later. Okay, so in setup, what we're going to do is just, like I said in the comments, we have to size the screen and turn on 3D rendering. So first of all, to size the screen, we use our size method, just like we have done before. But we're going to add a third parameter to it, and that third parameter is the one that turns on our 3D rendering. Okay? Now, for that to work, though, we have to have an import statement. So if we go up to our tools sketch method, import library, and OpenGL, that puts an import statement up at the top of my program, and I actually prefer to have those after the comment, so I'm going to move it down. But now I'll be able to run a 3D rendering program. One more thing that I didn't actually list in the comments, but we'll do anyway, is to turn the stroke color, the pen color that we're going to use to draw lines with, to white, and that'll help us see the wireframe of the cube and the sphere. Okay, so that's the end of my setup method. If we try to run this, it should run appropriately. It doesn't really do anything yet, but it works. Okay, so now we can go on and we can work on our draw method. Now, things are a little bit different here. Anytime we do animation, we have to erase the background on every cell or every frame that we're going to make. So I'm going to set that to black, and then I'll start drawing after that. Now we're going to make our line. And we'll use a line method to do that. What's a little bit different about this is that we have to add z coordinates to our line method because now we're drawing in 3 dimensions instead of just 2. So I've got my x, y, and z for the starting point, x, y, and z for the ending point. We can run this now, and I should have a black screen with a white line, which is what I want. And now I can get on to the main part of it, which is to think about moving things around. Okay? In 3D, we have to do this a little bit differently. We move things with the translate method. So we're going to move the shape in the XY plane based on mouse location. And we do that with a translate method call, like I said. So we're going to translate or move our shape to wherever the mouse is, mouse X, mouse Y, and we'll keep it flat in the Z coordinate, so we're on the XY plane. Then what we have to do is decide on what shape we're going to draw. Okay, so if our mouse X location is less than the width of the screen divided by 2, that means that we'll be drawing a red box. So we'll call our fill statement first to make the color red, and then call our box method. And we'll go ahead and for right now, we'll just put in a number there. Will be the number of pixels in that box on each side. Okay? So there's our box method call. Now, if we're not on the left-hand side of the screen, then what we have to do is draw our green sphere. So we're going to change our fill color to green instead of red, and then we'll do a sphere call instead of the box call. So now we've got our drawing pieces. Okay? I like to put those comments at the end of methods and if statements to help associate the bracket with its actual starting partner. That way we don't get confused when we're coding. Okay, so if we run this now, it should work. On the left-hand side, I get the red sphere. You can see how that changes in perspective as I move it. And as soon as I cross the line, then I get my green sphere. So it's a red cube, sorry, and a green sphere. Red cube, green sphere. Okay? Now there's one more thing we should take care of, and that is the idea of magic numbers. So right now, if I wanted to change the size of the box and the sphere, I'd have to go ahead and I'd have to change this number. So let's say I wanted to make it bigger, and this number, and then recompile my program. Now I've got bigger solids than I did before. Okay? If I wanted to change them back, I have to change it in 2 places. Now that's not so bad, but if you imagine that maybe I've got hundreds or thousands of different shape calls in my program, so it's a really big program, going through and changing every one of those would be very error prone. So instead of using a magic number like that, what we're going to do is we're going to declare a constant up at the top of our program. So we declare constants with the word final. This will be an integer, and we'll call it shape size. So for constants, we use all caps, and if there's more than one word, we separate it with underscores, and I'll set that equal to 75. Now down here, I'll use that constant here instead of the magic number. Okay, so now I've got a program that should still run for my original shape size, but it's a lot easier to change. So now if I want to make it, let's say, smaller, I just change it in one location, and now my solids are smaller. Okay, so that's the benefit of using those constants. For one thing, it makes it easier to change, and then also it makes it easier to understand what this is down here. Shape size, there is the size of the box that will be drawn. Shape size is the size of the sphere that will be drawn. Okay? So there we've got a 2-armed if program that also renders shapes in 3 dimensions. Cool, huh?